Hello, this is Jeff Scott of Rankin Technical College. I've been going over the PowerPoints and some code examples for Farrell's Microsoft Visual C# 2015 and Introduction to Object-Oriented Programming. And I'm now going to go over Chapter 11, which is exception handling. And what I've done is it looks like I've got 6 programs, but really I've got one program that I wrote and I rewrote 5 times. So I'm going to give you examples in here, and if we look quickly at the examples, hopefully you can see this okay. The first example that's here will use no exception handling whatsoever. And you'll see what will happen when we enter in bad values. Again, the program is simple. We'll look at it in just a minute. The second example, we use an if statement or if statements, but we don't use any object-oriented programming type of exception handling. On the third example, we're going to use the try-parse statement. And then I've got 3 different examples that go through and actually use object-oriented programming methods. Now again, as always, and as I've said many times, you don't become expert or very knowledgeable in this stuff without doing it. So I'd strongly suggest that you go and create some simple programs of your own to test this stuff. But let's bring up the first one. And again, I will bring these up in order. As mentioned, this is a very simplistic example. It's GUI program, but it's a very, very simple GUI program. There it is. So here is what it looks like. In fact, let's just run it so you can see it in action, so to speak. So what we have here is 1, 2, 3 labels, one that says input number 1, one that says input number 2, and one that says result. We have 3 text boxes. One where we put the result of our first input, one that we put the result of our second input, and the result, which is the first input text box value divided by the second input text box value. When we click calculate, we cause the division to actually take place. When we click clear, we clear out this, we clear out this, we clear out this, and we put the focus right here. And when we click exit, of course, it ends the program. So if I run this and I put in numbers that make sense, like 34 and 2, you'll notice I get 17.00. I have formatted the answer to 2 decimal places. All right? But what happens when I take 34 and I divide it by 0? Well, I get some kind of a thing there. I don't know if that's the infinity symbol or what, but the good news is the program isn't breaking. But what if I put nothing in there for input? So I'm going to click clear, so it's all empty, and I click calculate. Well, notice what happens. All right, this is bringing up the exception handling dialog box. It says format exception was unhandled. Why? Because what I attempted to do right there was to convert the value that was in the text box to a 32-bit integer and then put it num1. Since there was no value in there, it failed. Now you'll notice that if I stop the run and start it again, if I do come in and actually put in a valid value for the first one, but I leave the second one, the same thing will happen. But now it's this one that gives me the error message. All right. So in both cases, the system was looking for me to put in an integer, and I did not do so. Well, what if I put in something that's not even numeric? Hello, world. And I click calculate. Well, you notice the same thing happens. And again, if I run it again and put in for the first value, 34, and the second value I put in world, again, same kind of thing, but it's num2. So you see a pattern emerging here. Finally, if I run this one last time, and I put in something in here that's 34.8, so it's not an integer, 3, and I click calculate. Well, notice again, it's telling me in each one of these cases, I have a format exception. I'm doing something that the system isn't expecting me to do. with all that said, if I do come in here and I put in a number here and I put in a number here and I click calculate, everything works just fine. So when we look at this and we look at the associated code here, what I want to get across to you is, again, hopefully everything that's in this clear routine just makes sense to you now. We don't have to go over it. And the exit, same kind of thing. I did set it up to try to guarantee that the focus will be in the first text box when I start. So the code that we want to concentrate on is right here. It's the code that takes place when we actually click the button. You'll notice too, I put all the code inline rather than calling different methods. Because my goal here is not to be modular, but my goal is to try to explain to you error and exception handling. So if we look at here, notice how the comment says, no exception handling done. So you see we attempt to take what's in the first text box and convert it to an integer, attempt to take what's in the second text box and convert it to an integer, divide the first one by the second one, and because we want to keep the decimal place, we are doing right there, that's called a cast, so we're casting it to a double, and we're putting the result in the double. Then the result of the multiplication, all right, we're putting it into our text box result, and we're formatting it to 2 decimal places. All right, hopefully that's enough of a little bit of an intro here. Make sure I'm still taping. Yes, I am. Hopefully that's enough of a little bit of an intro here to get you started to figure out what we're talking about. All right, so that's the first example. All right, then what I did, and I literally got out just to show you this, I'm going to get out every single time and start the system back up, is I took this folder and copied it to this one, and then I renamed it. The reason I'm telling you that is notice when I double click on the first folder, it says Chapter 11 exception handling, no EH for no exception handling. But when I click on the second one, this one says Chapter 11 exception handling 02, Nanu, but if I click on it, it says Chapter 11 exception handling 01 dash no EH. And the reason I'm telling you that is I wanted you to understand what I did with each one of these was I took this and I basically just copied it. All right, so let's take a look at how to do this with exception handling, but without any object-oriented exception handling. So you see that we have the exact, and I mean exact same interface. All right, so now we're coming in here, and you'll notice this is bigger. Guess I don't need it. Okay. But no, look what we're doing. What we're doing is we're coming in here, and we're still going to have a problem because we're not checking these values to make sure that they're correct. So let's run this. And I'll just click calculate. And again, you notice we get the format exception that we had before. I'm not going to run through the myriad of examples that I did the first time because they'll work the same way. What's different is now this time, if I attempt to run the program and I attempt to put in a 34 here and a 0 here, now when I click calculate, it comes up with a message box that I created that says cannot divide by 0. That's the title, and it's an error, and it says illegal attempt to divide by 0. And when we do that, I clear the value out and I keep you right there. So as soon as you put in a value that makes sense, everything works just fine. All right, other than that, it's the same program. So let's take a quick look at this. Again, this part right here, that's the same as what we had before. All right, but now we're saying if that second number is not equal to 0, then actually do the division, etc. Do everything you're supposed to do. And notice, I think this is an important point. Notice when we look at this, notice what I've got first in the actual if. What I put in the if there, all right, because I'm going to test that every time. I should put in the thing that would be more likely to be true than the one that's more likely to be false. And what I mean in English by that is, it's more likely somebody's going to put in an input that's not 0 than they are put in an input that is 0. So if you've put in, if it got through this, okay, so we have two numbers in here, two integers, and if the second one was not 0, do the division and put the result in the text box. But if this if is not true, that means we hit the else, and the else assumes that we did input a 0. So again, we put in a message box that says illegal attempt to divide by 0. That's the actual text that we get. This is our title, cannot divide by 0. We only put an OK button in there because this is just informing people of things, but it is an error. So we put error there. Afterwards, we come back and we take what was in that text box, we set the text to the empty string, and then we reset the focus. So that's a little bit better. The problem is, again, with what we've done so far, in both the first example and the second example, if we do this, and we put something in that's either empty, non-numeric, or non-integer numeric, we're going to get a format exception. All right? So keep that in mind. So that's the first two. Then for the next one, it's called Chapter 11 Exception Handling 03 Try Parse. So again, we're hopefully building towards something that's bigger and better all the time. You will again notice that if we look at this, by now that should look very familiar to you. I use the same colors, the same everything with each example that's on here. All right? So what's changed? Well, again, nothing's changed in our clear and in our exit, okay? But now in our calculate, notice what we have. This says attempt to take the number that we put into the first text box and convert it to an integer. Okay? So attempt to do that. If it worked, actually do the conversion. But if it didn't work, meaning either A, we left it blank, or B, we put in something that was non-numeric, or C, we put in something that was numeric but that was not an integer. So let's look at all three of those cases. We're going to put bad stuff in here. We'll leave this blank. Notice illegal input for number 1, and it keeps us right there. If I put in something that's non-numeric, illegal input for number 1, and it keeps us there. If I put in something that's non-integer but is numeric, illegal input for number 1. All right? So that handled that. And if we did put anything bad, we bring in the message box that you just saw. We set the text to double quote, there's nothing in there. We set the focus to that field, and we return because we're done. We want them to try it again. Then we do this code that you see right here, this code that you see right here in blue, that code. Move that down so you can see everything. That code that's right there in blue. We then take all of that code and replicate it down below. So this is the exact same code. The only difference being, instead of saying text box number 1, we say text box number 2, and instead of saying num1, we say num2, and instead of saying number 1, we say number 2, etc. But we're doing the exact same thing. So again, if we run this, and we'll put in a valid value for the first number, leave the second one blank. Now it says illegal input for number 2. Non-numeric input, same thing. Numeric, but non-integer input, same thing. All right? So if we put in bad input for number 1, we just clear everything out and return, which means get out of the routine. If we get valid input for number 1 but invalid for number 2, same thing. So if we get down to here, if we get down to this point here in line 58, what that's saying is that we put in 2 numeric integer values. But the second value could still be 0. So if it's not 0, do the math. But if it is 0, just like we did earlier, give us the error message. So if I put a 0 in here, cannot divide by 0. This isn't the same message that we get if it's empty. That says illegal input. This one says cannot divide by 0. One thing that you should always strive for when you're writing code is, when you're starting to do this and you're handling errors and you're writing message boxes or doing whatever, you want to make sure that what you put in there, that what you're letting the person running the program see is something that's going to actually help them. Okay? In other words, what I mean is, the idea here is we're putting a message in there that they can understand and hopefully take some corrective action. All right? So that's the first 3 examples. None of these examples, again, they've gotten progressively better, but the first example, remember, had no error handling at all. The second example, that was called non-oop, all it did was it had an if in there that checked for the second input being 0. That was it. The third one, the one that we just looked at, all right, did the try parse. So by the time we got down to where we were doing the check to see if the second number was 0, we could be 100% certain that the values we put into those first 2 text boxes were both integers. The second one could still be 0, but it's at least an integer. So let's take a look at 3 different OOP methods, object-oriented programming methods, to handle this. Again, the exact same interface because we've just copied. All right. So now, again, the exit, the load handling, the clear, that's all the same, but this has changed. All right. Now, this is the first example in which we are actually going to use a try-catch block. And I even put a finally in here just to show you how that can be used. So let's take a look at all this. This says attempt to convert what's in the first text box to an integer. Now remember, if we attempt to do that, so let's run this. And I'm going to leave it blank as we did before. Calculate. Illegal attempt, resetting to default value of 34 for number 1 and 2 for number 2. So we forced it into working, for lack of better words. What this said in English was, okay, attempt to do that conversion. If for some reason that one fails, or for some reason that one fails, all right, if either one of them fails because we left them blank, or we put in something non-numeric, or we put in something that was numeric but wasn't an integer, that'd be a system format exception. So that's what we're catching here. So attempt to do this. It's either going to succeed and you're going to skip the catch and go right down to this finally, or one or both of these are going to fail, and whatever one it finds it fails, it says, oh, okay, well, what's the problem? And this is going to be the problem. So again, what we did was we said illegal input, and I basically forced it into working. Right there. Now, many people would tell you that that's kind of an egregious, not a really good way to do this. All right? But I did it this way to show you that indeed it can be done. What I'm saying is it is possible for you to literally force your user to put in valid things, because if they don't, you will actually put valid values in there for them. So that's the third value. And again, remember, whether the try succeeds and we skip the catch, or one of these statements in the try fails and we do the catch, in both cases then, we come down and do the finally. Because we either had 2 valid numbers to begin with, or we replaced anything invalid with 34 and 2. So now we can come through here and say, again, if it's not 0, do the math. Otherwise, give me the error message. All right, so that's our first example jumping into the world of object-oriented programming for error handling. The next example, This is just a build on from the previous one, but I do want you to understand that technically there was nothing wrong with that first example. There was nothing wrong with it. So why am I showing you another example? Well, notice what we have in here. If this succeeds, okay, so we're only checking the first number. If it succeeds, if we were able to do the conversion, then we've got this flag, this Boolean variable that's called valid input 1, and we're initially setting it to false. We're assuming bad input. But if this succeeded, then set our flag to true. All right, otherwise, we're just going to reset it to false. We could have just left it, but you'd have to do some more code in there, okay? Then we do the exact same thing in the second one. And I left the finally out this time because we've got one try catch here and one try catch there. I could have actually taken all this stuff here and put it in the last finally block probably. So there's a lot of different ways this could be written. But let's run this. And again, I'm going to leave it blank. Resetting just the first one to 34. All right. Oh, I guess we're doing the second one too because it was blank also. But let's say that we run this again and let's put in a number. We'll put 14 in here and we'll leave the first one blank. So it says, okay, resetting it to 34. Doesn't have to reset the second one because it's already valid. So it does the math. Well, let's try this where we make this a non-integer value and we run it. It says we've got a problem with number 2. We're changing it to a 2 and then it does the math. If we put in something non-numeric, same thing, change it to number 2 and there we go. And the same thing would happen with this. If we left this in, we'd say the error was a number 1. We'd set it to 34 and boom. If we left it blank, same kind of thing. And if we put in something here that's non-integer, same thing. So this is a second way of handling this. Is this way better than the last way? Well, the advantage of this way is since we're doing each statement in its own try-catch, if there's a problem, we can let the system know that it happened in input 1 or that it happened in input 2, which we didn't have the luxury of that the first time, the way that we wrote it. Okay? So that's a second example of doing this in an object-oriented way. Now, the last example that I decided to put in here, and again, not so much that we needed to do this, but in this last example, and it's probably going to fail. I'll make it fail. But again, you can see the same exact interface. But if we view the code, two things. First of all, I wrote my own exception. Okay? And if I put in for either one of these values, either one, if I leave it blank, in fact, I think maybe the only thing I checked in here was, let's see. Oh, we've still got the stuff from here from before. But now, if the second number was not 0, do the math. Otherwise, clear it out, but throw a new exception. So this one runs just like the other one did, as long as I don't put a 0 in there. So if I put a 34 in here and a 2 or a 3 in here, that's fine. It does the math. If I leave this blank, I get what I got before. It resets it. If I leave this non-numeric, same kind of thing. If I take this, let's make it pi, 3.14159. Same error, all right? Where this changes, and I actually purposely have the program blow up if I put a 0 here, all right? Illegal attempt to divide by 0. And it blows up right there. And it's showing here that it says additional information, illegal attempt to divide by 0. Well, why am I showing you that? Who cares? I'll tell you why. Remember that it says illegal attempt to divide by 0, because that information was this information. So in this very last example, what I have done here is I have provided my own exception handler. Now, if I go out to Google here and I type in here types of C# exceptions, I'm going to sooner or later, there we go. I was going to say sooner or later I'm going to get to MSDN, the Microsoft Developer Network. But if we look in here someplace, all right, they're showing me the exceptions here. Application exception, invalid operation, argument, null reference, Stack Overflow, etc. So they're showing some of the errors. I wanted to see all of them, but let's see if we can find that. It's an exception hierarchy. I don't know. Actually, this looks pretty good here. C# list of exceptions. But that's from Stack Overflow, so that may or may not show them to us. Let's see. Common exception classes from the Microsoft Developer Network. Let's see if we get anything from there. Got quite a few things open, but the system has been running very slow today. This is good. All right. Notice what it shows us here. Arithmetic exceptions, array mismatch, type mismatch exceptions, divide by 0, index out of range, invalid cast, null reference, out of memory, overflow, etc. There's a lot of good ones in there. Again, they say common ones, but let's do one last thing. C# system.format exception. That's the one we called. So let's look at that. And as you can see, we can go to the Microsoft Developer Network and find out information about that one. How did I know that it was a system format exception? Because I put something illegal in there so that an exception was thrown, and then I recorded the type. All right. So here's probably all the information that you'll ever need on that particular exception. So what I have done in this very short half-hour or so lecture is this time I didn't take the time to build the application in front of your very eyes. And the reason I did not do that was because I figured that by this time this was a very, very simple exception, or a simple example, I should say, with exceptions. So what I did was I built the same thing and progressively added different types of error handling or exception handling into it so you could see what was happening. Okay? All right. I'll be back with another lecture shortly.